Hi, I am Alonica Toledo, a mechanical engineering student from the Polytechnic University of the Philippines, and today I will be discussing the refrigeration cycle using the schematic diagram. Refrigeration is the process of transferring heat from one place to another. The mechanical refrigeration system has four stages taking place in the compressor, condenser, expansion valve, and evaporator. It is divided into two sides, the low pressure side and the high pressure side. But before we go to the refrigeration cycle, let's first define its major components. First is the compressor. The compressor is known as the heart of the system. It compresses the low-pressure gas refrigerant to high-pressure gas refrigerant, also increasing its temperature. Second is the refrigerant. If the compressor is known as the heart of the system, the refrigerant is known as the blood of the system. A refrigerant is a fluid that boils at a lower temperature. It absorbs heat in the evaporator and discharges it into the condenser. Third is the evaporator. The evaporator is a coil of tubes where heat is being absorbed in order that it may be moved or be transferred into the condenser. It is known as the freezer, cooling coil, or cooling unit. It can be found at the low pressure side of the refrigeration system. Fourth is the condenser. The condenser is also a coil of tubes where the heat absorbed in the evaporator is discharged into the atmosphere. It is found in the high-pressure side of the refrigeration system. Last is the expansion valve. The expansion valve is a metering device that controls the flow of the refrigerant to the evaporator. It reduces the high-pressure liquid refrigerant to a low-pressure liquid refrigerant into a correct quantity to operate the system at maximum efficiency and without overwhelming the compressor. There are many types of expansion valve. One example is the capillary tube. At point 1, the low-pressure, low-temperature liquid refrigerant passes through the evaporator wherein it absorbs heat from the foods placed inside the refrigeration cabinet, thus turning the refrigerant into gas. It is then drawn into the compressor. At point 2, the low-pressure, low-temperature gas refrigerant moves to the compressor wherein it is subjected to a higher pressure due to the compression process done by the piston and cylinder unit inside the compressor. As a result of being compressed, the low-pressure gas refrigerant increases its pressure as well as its temperature. At point 3, the high-pressure, high-temperature gas refrigerant moves to the condenser where the heat is discharged in the atmosphere. It turns the refrigerant back into liquid, but this liquid is still high-pressured. At point 4, the high-pressure, high-temperature liquid refrigerant passes to the expansion valve wherein the pressure is reduced. The pressure decrease also decreases the temperature, and now the refrigerant is ready to pick up more heat. The refrigerant will then arrive at point 1, wherein the entire cycle is repeated. For further understanding, I will next discuss the refrigeration cycle using the pH and PS diagram. The pH diagram is a figure with a vertical axis of absolute pressure and a horizontal axis of specific enthalpy. The PS diagram, on the other hand, has the absolute temperature indicated on the y-axis and the specific entropy indicated on the x-axis. The behavior and the shape of the curve is different in both diagrams, but the structure is the same. The saturation vapor curve has a critical point which separates the saturated liquid and the saturated vapor. The area beyond the saturated liquid line is the compressed or subcooled liquid region. The area beyond the saturated vapor line is the superheated vapor region, while the area inside the saturation vapor curve is the wet mixture region. At point 1, the low pressure, low temperature wet refrigerant passes to the evaporator wherein heat is absorbed. The addition of heat will effect a change in the phase of the refrigerant, turning it to saturated vapor. At point 2, the gas refrigerant moves to the compressor where work is done. The compression process increases the refrigerant's pressure and temperature, turning it into superheated vapor. At point 3, the high pressure, high temperature superheated refrigerant passes to the condenser where the heat is discharged into the atmosphere. This turns the refrigerant into saturated liquid. At point 4, the high pressure, high temperature liquid refrigerant moves to the expansion valve wherein the pressure is reduced. The pressure decrease also decreases the temperature, turning the refrigerant back into a wet mix state. It is then ready to pick up more heat, and so the cycle is repeated. I hope you learned anything today. Once again, I am Alonica Toledo, a mechanical engineering student from the Polytechnic University of the Philippines. Thank you for watching.